Hello, in this video we want to explain to you about the digital load control errors. In the previous video we explained to you how to set the load control. So stay with me. Well, in the previous video we explained to you how to set the load control. In this video we want to explain to you about the digital load control errors. And if you see an error, first find out that the problem is and then fix that error. The first error message is OL and it will show you on the screen here, which will show you on this small screen that this error means the load control is higher than the current you set. If the load control is greater than the value we entered from the off time, for example, 15, whose diagram is clear here, which the current second diagram whose duration is equal to off. This chart should be obtained for each motor to obtain the exact timing value. LOD letters will be displayed for you, which indicates overload. When the word LOD is displayed, the OL LED will blink. So LED OL will be linked and LOD letters will be displayed here. And you must have entered the cutoff the time based on this diagram in the off section. And this is the overload error. In the next fault that is activated, the LED UL will be activated blank. This means that this LED will blink and the no load error will be displayed. That is, the current value is less than the value you entered in the UL field, and the duration of the off U interruption and the letter UNC will be displayed for you. It means the reduction of current caused by no load, which you cut according to the off time of U. In the next error is the asymmetric of the load, which caused the LED A% to blink, and the letter UBC is displayed, and the cutoff time is equal to the off value. When these errors are resolved, the on-delay time, the normal LED will be blank and displays the previous error message. The point we want to explain to you is that you can determine the status of this relay and you can ignore these errors in the settings. And you want to ignore these errors and be connected in any mode. Okay, hold the enter button for 2 seconds here, and the RC means that this load controller is connected in a fault mode, which you can change and connect in the normal mode. When you change from open to close mode, a connecting sound is created inside the load control. It changes the state of the relay, which is now open. If we take it now in a close mode, and this changes to bottom part. This was a short explanation about the errors of this digital load control device. You must pay attention to these errors, and In the next video, I will explain the complete wiring of this load control. But there is a section below called auto that if you connect the fuse to auto, the device will reset automatically will on delay plus 1 minute, which is displayed as a reverse number, and the device is not reset manually. If you want to reset manually, you should hold the top and the button together to reset. When you connect the fuse to auto, the device resets automatically, and it is duration is on delay uh, plus some 60 seconds. When an error occurs, and even if the error is not fixed, it will be automatically reset after the specified period of time. This action happens 3 times. For the 4 times, you have to do this manually. You should pay attention to this point. Let me explain another point. When a symmetric occurs, UBC layers will be displayed, which has two influencing factors. First, you set the A% value to low. If we increase this number, the sensitivity of this load control will be decreased. If we set it to 7, even more than 7% of currents become asymmetric, you will stop this load control. We can put it amount on 40%. Even more than 40% of currents become asymmetric, you will stop this load control. First, you need to increase this A% to show less UBC error. The second is that the currents R and T must be symmetrical. For S, they didn't put trans city. They put a trans city only for a R and T. So it is better if additional current is for something. For example, S base should be used for lighting and other parts so that R and T are not symmetrical. So you should consider these 2 points. So this symmetric current shouldn't be reserved from R and T. So it is better to reserve that than S, because this control doesn't recognize the load. It only measures the value of these two. Well, that was a complete explanation of the load control's errors. In the next video, we will explain to you about the wiring of this load control. Thank you for watching this video. Bye.